This section is all about parametrics with calculus, and the first thing that we usually learn about calculus is how to take the derivative of something. So say we have the parametric equation x equals 1 minus cosine t and y equals 1 minus sine t. To take the derivative, dy over dx, we are actually just going to do dy dt, the derivative of the y function, over dx dt, the derivative of the x function, which can also be written as y prime of t over x prime of t. For this specific example, dy over dx is equal to negative cosine t all over sine of t, which can also be written as negative cotangent t. And this will be the slope of the tangent line to your parametric equation at some t. This is how we find the first derivative of your parametric equation. However, the second derivative, d squared y over dx squared, is a little bit different. It's not just y double prime t over x double prime t, but it's actually going to be the derivative of your first derivative all over your first derivative of your x value. So in the case of x equals 1 minus cosine t and y equals 1 minus sine t, your first derivative is equal to negative cosine t all over positive sine t. Your second derivative is going to be equal to 1 over sine cubed t after simplifying everything. Next, we're going to learn how to take the area under a parametric curve. We know that the area is equal to the antiderivative from some a to b of your y function with respect to x. We can substitute this dx and change the boundaries so that our area is integral from some alpha to beta y of t times x prime of t with respect to t. So now if we have x equals 1 minus cosine t and y equals 1 minus sine of t, then the area from some t between 0 and 2 is going to be the antiderivative from 0 to 2 of 1 minus sine of t multiplied by sine of t with respect to t. It'll be very likely that we see an AP problem involving parametrics that asks for the speed of the particle. Now, if we can remember our speed equation, which is the square root of x prime of t squared plus y prime of t squared, then we'll be able to just plug in our parametric derivatives and solve for that. The other question relating to speed could have something to do with the distance. And if we remember, distance is just the antiderivative of velocity. So if this speed is essentially our velocity function without direction, we could also say that it's equal to the antiderivative of the absolute value of v of t, our velocity function, with respect to t. For a parametric curve, distance can also be represented by the arc length, which, if we remember, is our formula, the integral from a to b of the square root of 1 plus dy over dx squared dx. We can shift some things around and say that our arc length for a parametric function is the square root of dx over dt squared plus dy over dt squared with respect to t instead. If we distribute our dx here into the equation, this is what we're going to commonly use for parametric arc length, which we can use in reference to the distance of some sort of particle traveling on a parametric curve. Because if you look at it, it's similar to the antiderivative of our speed equation. Let's say we have the parametric equation x equals 1 minus cosine t and y equals 1 minus sine t. And we want to find where the graph of this parametric equation is concave up. First we're going to find dy dx, which is equal to negative cosine t all over sine t. We're also going to need our second derivative if we want to do the second derivative test. So d squared y over dx squared is going to be equal to 1 over sine cubed t. If we see where the critical numbers for dy dx is at t equals 0, pi over 2, pi, and 3 pi over 2. Then we can set up our interval chart. 0, pi over 2, pi, and 3 pi over 2. We're just looking between the interval of so we're not worried about what comes before 0. Say we look at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. If we plug these back in to our second derivative, then we're going to get positive, positive, negative, negative, which means that the graph is concave up from 0 to pi. Let's say we have our same equation, x equals 1 minus cosine of t and y equals 1 minus sine of t. And we're asked to find the total distance traveled on the interval 0 to pi over 2. When you see total distance, that's when you're going to want to use arc length. So if we take the integral from 0 to pi over 2 of the square root of the derivative of x, which is going to be sine of t squared, plus the derivative of y, which is going to be negative cosine of t squared with respect to t. We can simplify that to the square root of sine squared t plus cosine squared t, which is just equal to the antiderivative of 1, which is just t by fundamental theorem of calculus, pi over 2 minus 0. The answer is going to be pi over 2. That's the total distance traveled.